Yo, what's up?
Good afternoon, Professor.
Video 6.
Physical behavior matter. We're going to show you about heat of reaction. So a chemical reaction absorbs or releases heat depending on the types of bonds that are formed and broken. And we're going to kind of show you the table that we use to figure that out.
Yep. Exo versus endo, baby.
Yeah, it's
Let's
pretty
do it.
straightforward. So
first up, exo versus endo. So endo is the tough one, in my opinion, to remember. Because I remember exo and then I figure out endo, but endo is heat is entering the system. Specifically, my delta H, my triangle H, delta change in H will be positive for endo.
because what it means is that the reactants had less heat than the product. So the overall amount of heat is a positive value. It's increased.
We're getting into that place of this whole unit where we have to start looking at it from the system itself.
Right.
And the system is gaining heat. Exothermic is the one I think of easy because exo sounds like exit.
Yes.
Heat is exiting, and so therefore I have a delta H straight up exiting the room. I have students exiting my room. All of a sudden I have less students.
Right. So
Heat exits, I have less heat.
the reactants have higher energy than the product. So the heat that they release leaves.
You did a really good job of keeping your hands right.
On the right side. Yeah.
You did
Thank
really
you for
good
that.
job.
So exothermic chemical reactions are the way we figure out the amount of heat is we always do heat of the products minus the heat of the reactants. And that is when we get the sign with delta H. So if delta H is negative, it means that there was more heat in the reactants and that heat is exiting the system. So again, products up over here on the left, reactants down here on the right, heat leaves the system, negative value.
And then the opposite is true for endothermic. We still have to keep the math the same. It's always products minus reactants. We have to do it in that order because subtraction is not cumulative, right? But now I have a positive delta H because I had reactants here, added heat, and now my products have more heat than my reactants did. And we're going to see how we actually measure those in charts here before too long.
Okay, so for an example, here's a chemical reaction. It says that carbon dioxide gas decomposes into carbon solid and oxygen gas.
Right.
And the table I has this equation listed just as you see it, and it says the delta H value is negative 393.5 kilojoules per mole.
But look at the difference between the two chemicals.
Right. Oh, it's the same reaction, but it's been flipped. So if the first reaction says the carbon dioxide becomes carbon and oxygen, the reverse of it would be the carbon and oxygen become carbon dioxide, which is what you see on the chart. So you switch the sign on the heat involved if you switch the direction of the reaction arrow.
Exactly.
Kind of makes sense.
Yeah, these two are like the games you play. If we're not just straight looking them up, these are the two games we could play in the meantime. So the other game we could play is take this reaction, and I find it's this exact reaction on table I, but I notice, it's doubled. So if I double the amount of stuff, I'm going to double the amount of heat.
So switching the reaction backwards switches the sign on delta H. Doubling the reaction doubles the value of delta H, but keeps the same sign.
And halving the reaction would
cut it in half.
There you go.
Exactly. Yep. I don't think we do that halving too often, but doubling I think might be on the test.
Yeah, doubling is probably more often, but it can go either way, so we got to do that, and we got to be able to do it either way.
Cool. So here's that same chemical reaction that we've seen before. The delta H value that we would see written off of our table I is negative 566 kilojoules per mole. It releases a lot of energy when this happens because carbon dioxide is very stable.
Now all I got to do is look at the sign to tell you if it's exo or endo.
Oh, it's a negative sign, so that's exothermic. Fact. And now this reaction, I think, was just straight up the same off of the
so RTS remains the same.
Remains the same. Write that in that last box there. Okay. Next reaction.
N2 plus O2 goes to NO2 gas. Notice, first of all, they're all gases. That is going to help us. Some of them are really close. There's one where water is a product and it's a gas, and the exact same reaction where water is a product and it's a liquid.
Right.
They're right next to each other, and they have different values, so please pay very careful attention. We looked this one up. It has a positive 66.4.
Yep.
So positive tells me instantly that it's
endo.
That's right. And then we got I know with that one, It is not double.
Right. Well,
Is there any chance it's halved?
No, it is just the same. So
Just the
nothing
same.
remains the same.
Yep. So it remains the same.
Remains the same. Next reaction: 2 hydrogen gases plus 1 oxygen gas makes 2 H2O gases.
Oh, here's the one where liquid is right above it. Isn't
Let's see here. We got 2 hydrogen gas plus oxygen gas makes H2O gas, and the one right underneath it is hydrogen gas, oxygen gas, water, liquid. So you got to be careful. But this one is straight up negative 43.6 exothermic.
Got it.
And it was exactly the same as I saw it on table I, so I didn't have to double it, halve it, or anything. So it remained the same.
Okay, cool. Next one is, oh, whoa, wait.
Yep.
Hey, look, that
But-
one is switched.
And it's a different
Oh, it's
reaction.
the liquid too. Check it.
It's
It is
the liquid one. So we would find on table I, would find that reaction and decide, oh, there it is. There's H2O liquid, but hydrogen,
It says
Flipped
negative
it's negative 571.6.
So
This
this
is
one's-
positive 571.6
because it's flipped.
because we flipped the reaction backwards.
So now the what was exo becomes
Endo.
endo, and then here you're going to write doubled in that space.
No, it was not doubled half.
Oh,
It
you're
was-
right. It was.
It was flipped.
was
So you're going to have to write
flipped.
flipped in that space.
Yeah, reversed.
Reversed.
Yeah.
Reverse. So this lesson's pretty simple because we need you to remember 2 things. If you see a chemical reaction and it wants to know what the heat of the reaction was, you go to table I.
Yes.
The second part of that is if you see the reaction flipped
Sorry, guys.
or doubled, you have to flip the sign of delta H or double the value of
Yeah.
delta H.
Uh-huh. And then the first thing we learned in the video was negative is exo, positive is endo as far
That's
as my
true.
delta H values. You got that down, and you got this whole lecture down, and we good to go.
That's one entire reference table just of list of chemical reactions to tell you if they release energy or absorb energy. And then the number tells you if it's a lot or a little bit. Guess what? A big number is a lot of energy.
Yep.
A little number is a little bit of energy
Relative to each other.
relative
Facts.
to each other. So
Hey,
thanks for
I see some
watching.
buttons.
I'm going to click these buttons and I'm going to turn off this here video.
Yeah.
Where are they? Where's that button? There it is. Oh, stop.